A hotend where you can change the nozzle in only 6 seconds. Beautifully 3D printed pictures and 3D prints that were left outside for 7 full years. Were only some of the things that I saw this year at the Rocky Mountain RepRap Festival in Loveland, Colorado, which is just an hour north of Denver. Sit back and join me on this trip to see some amazing new technology and stunning maker projects. Let's find out more. Guten Tag everybody, I'm Stefan and welcome to CNC Kitchen. This video is sponsored by Squarespace. Head to squarespace.com/CNCKitchen to save 10% off your first purchase of a website or a domain using code CNCKitchen. Since I'm based in southern Germany, I had to catch a flight to Denver. So one snowy morning I drove to Munich, met up with Jan from Jantech and hopped on a plane to Colorado, where we arrived in the same type of weather. So unfortunately no tour through the Rockies for us this year. In the end, it wasn't too bad, because we anyway spent the whole day inside the venue building, where the amazing organizers were able to secure double the space than last year due to the overwhelming success of the event. RepRap festivals or maker fairs are always amazing to be at, because there are so many kind and like-minded people who share their passion in making something unique with each other. There were so many things to see, and it honestly pains me that I can't cover all of them, but I picked some that I was sure were interesting for you, and I will share them in this and next week's video. So if you don't want to miss part 2, make sure to be subscribed and select the notification bell, because I'm sure you don't want to miss these projects. Let's first take a look at what Swiss 3DC had to show. They flew all the way from Switzerland to the US to show their new hotend, which allows you to change its nozzle within only 6 seconds without the need for tools. Ever since E3D brought their Brevo to market, toolless nozzle changes seem to be the cool new thing. But now to the Starlex DHB hotend, which uses a different approach.
We developed this new product. It's a tool-free hotend. You can change it in 6 seconds. We have the Revo, and everybody knows it's a great product. You turn 10 times to take it out, and put 10 times to turn it back in. And here, how many turns did I need to take it out? That's how fast it was. You have it, put it back in, it's done.
The two halves are held together by a metal clip that sits inside of the silicone sock. Let's take a closer look at the dual heater blocks that give the DHB hotend its name.
Another thing you want to see as well, maybe, just when take this off. Then we can also take this one off. So you can see we can just take this one off as well. No tools again. And there. Or you have the thermistor on the same side as a heat cartridge. You have 2 holes here. Typically for the Bamboo Lab, it's a very small bulb thermistor, and you can find in the market bigger ones. So you have 2 holes for the bigger ones and for the small ones. So it makes it very flexible. And then if you want to take it out, we'll just take this one out here. But first, we need to take out in this side. This will be a little tricky. Take this one out. I won't do it here right now. I need my glasses and stuff.
This 2-part system opens up some really interesting configuration options, because we could simply have a heater and a thermistor on one side, have 2 heaters on opposing sides, or even have 2 thermistors to check how uniform the temperature distribution is. I was curious where and how we are able to use them on existing printers.
So you can adapt this on many printers, on many heat sinks and extruders. Like there you can see, you have a 33mm long. It just changes the same way. So just put it back in. You have 2 heaters, one on the top, one on the bottom, or a long one on the side. So like this, you really heat the thing well. That's copper. Heat blocks. Just clip it the same way, and you can see here it's very stable. It doesn't move at all anymore. That's for the Prusa. The Prusa, you have a nozzle. That's a melting zone. It's 12.5mm. Then all the heat goes up into the heatsink through the heat break tube. Here I made the same length, so it's a quick changeover. I modified the heatsink to make it the same length. And here the difference compared to 12.5mm, here you have a 22.5mm melting zone. So it increases widely the melting efficiency and speed of your printer when you want to go high speed. That's the different parts we just adapt into the heatsink or into the extruder.
Lionel told me that besides some simple adapters, they will also have drop-in replacements, for example, for the Bamboo Lab machines available. Yet what kind of nozzle will we be able to get?
For a start, for sure, the brass nozzle, the 040608. Also then, very quickly, it will be the stainless steel heat hardened at a reasonable price. We also, even though it's all Swiss made and Swiss products, because it's a Swiss branch, we cannot afford doing this outside for all the design we have. So there's a price, but it will still be a very low price because we have a very good watchmaking industry. It makes it easy to build things not so expensive. So to get small parts, and that's all small parts, but there's no screw. This is a great thing. There's no wear somehow with this. You don't need tools to take it off, and that's what I want.
After seeing this, I of course was curious when we'll be able to buy it.
So you will be able to buy it, but that would be by beginning of the summer. Yesterday morning at 9 o'clock, it was the launch of this product. So we came here to show this around, and the people are very impressive and very like it very much.
I was really excited to see this new approach for quick-change nozzles, and I'm curious what a Swiss-made hotend will cost once it launches. I'll definitely follow them and make sure to get a sample. After Lionel finished his presentation, he showed me something really interesting which caught my attention.
One more thing maybe if you want to see. This is a V6 nozzle. I believe this will be better than done in the CH2.
He handed me a V6 nozzle with a small thin-walled insert. I could see that the insert was changing the shape of the melting zone, yet since I did know that the CHT patent that's used in Bontex nozzles covers many things in that regard, I was curious if Lionel thinks that their approach infringes on the existing patent.
I don't think so, because it's already past the first step of patents. And it's already a good sign. And the details inside, that's the novelty is a patent, and that was what is important.
Unfortunately, I could barely see the inside of the nozzle and therefore asked what they did.
How does it look in the outside? That's a 33 millimeter long. The outside would be like that. So we don't do anything machining for that compared to all the other ones. We just put a tube, or we just do it directly on this one to make this denting, make it work. And this, in my first tries, was something like 30% higher. So I need people to do it to confirm this, because I might not have the perfect machine for that. But I did the tests, and in my test, it was relevant.
Since I didn't cut a nozzle open yet, I can't fully say what they did on the nozzle. But as I understood it, they simply deformed the outside of a tube, giving the melt zone a different shape and therefore increasing the surface area. This is going to be really interesting because there is an E3D patent that is still under examination and that does something very similar. Yet this is the first sample that I ever got, and I'll definitely try it out and report on how it works. Inventing an innovative product or making unique projects is worth nothing if people can't find you and you're not able to present yourself and your work professionally. A great website is the first thing that you need. And Squarespace, who sponsored today's video, is the best way to start. Squarespace is all about making a beautiful web presence accessible. Creating it is super easy with a new Blueprint AI that will generate a custom template for you with just 5 simple content and design questions. Blueprint AI will also automatically fill your website with custom content according to your prompt. Easily adjust the results to your needs and you're ready to launch. If you go to squarespace.com/CNCKitchen and use the code CNCKitchen on checkout, you'll get 10% off your first purchase. Squarespace is a great solution for everyone, regardless of whether you are a maker who wants to present your work and collect donations, an artist who needs a portfolio, or a business who wants to sell products. Squarespace is the all-in-one platform for everyone. I've been using it myself for several years for my own website and highly appreciate how simple and easy it is to use and to maintain. Try it out for free using the link below or by browsing to squarespace.com/CNCKitchen, where you'll get 10% off your first purchase using the code CNCKitchen on checkout. Thanks to Squarespace for sponsoring this video and making this trip possible. So before we take a look at Stan's 3D prints that he left outside for 7 years, I talked to Steve from HueForge how they are able to make these impressive color 3D prints and what tools they use to characterize filaments. But what's a HueForge in the first place?
So a HueForge it's just like the tags you make, the multicolor swap tags you make, where you make them thick to get the solid colors. Instead, we make them really thin so that the filaments blend, because filament isn't opaque. And so you can take advantage of that. It's hard to do by eye, but you can take advantage of it with some software. And so HueForge is a software that'll tell you how the filament will blend when you layer thin layers of it together, taking advantage of the fact that it's transparent rather than trying to avoid the fact that it's transparent.
So HueForge is a 3D print with very thin layers where you can control the colors by the number of layers that you print on top of each other. But how does the software itself work?
So HueForge will take any image, most formats, and it will turn it into a mesh, an STL, just like a lithophane maker will. And then it will let you bring in your filaments and show, by adjusting sliders where to swap it, what it will look like in real time. But it doesn't generate G-code, it isn't a slicer. All it does is it generates the model file and then a list of commands for where to put the swaps into your slicer, and then your slicer can do the rest.
I reported on color lithophanes 2 years ago, which are in a way very similar, and therefore wanted to know what Steve's idea and motivation was when he started HueForge.
So my father-in-law asked me to make a print for him for a sign, and I printed it, and as I was setting it up, I said, I think this actually might look better backlit as a color lithophane. And so I did it, and it was fortunate because red, yellow, oranges blend really well. They're easy mode, and it looked great. And after I made that, and I've never been a lithophane person, I've been functional print person. And after I made that, I said, oh, I'd like to try this some more with some other colors and see how it works. And I couldn't make them work. It never knew what it was going to look like when it, I had hours of printing and then it didn't look right. And I said, I'm a software developer. I have some graphics experience. I think I can figure out how to make a tool that will let me do this. It was just for personal use. I was going to do this. And I did backlit for a long time, and then by the time I got my color model good for backlit, I ran into someone doing this by intuition and in the slicer. And at that time, I knew the color model well enough that I was able to say, okay, this is how it's going to work, and I can flip it around. It's a different model, but I can flip it around and get to that model quickly. And so that's when I started doing it this way. And eventually I realized that this was much cooler because no one was doing it. And there's other ways to do color lithophanes. And so that's where I kind of really went into this.
I was wondering how you select the proper filament for the image that you want to print.
That's a really good question. So generally speaking, HueForge sees things in luminance, so dark to light. So that's a really good way to start, is to just start layering things from darkest filament to lightest filament from bottom to top. But it's a little bit more complicated than that because you have to be aware of how opaque your filament is and how transmissive your filament is. Because if this white is too strong or this yellow is too strong, it will cover everything below it and won't blend. So it does take some experience to do. HueForge won't do it for you automatically. But generally speaking, you start from dark to light and bottom to top. And then as you get good with that, you can move to more advanced modes that separate colors out more specifically.
HueForges can sometimes look really complex, and I was curious if the software helps me to find the proper colors to recreate an image as best as possible.
It does not. And I always recommend to people that they don't try to do color accurate to start with. Pick some colors they like, make a color scheme they like, and start playing with that color scheme. Generally include a black and a white, and then a couple colors in between, and then learn how the blending works. And learn how the filament stacks and get confidence in the tool and your printer, then work towards the color aware and the color pop methods that are a little bit more complicated and more capable, but really require you to understand how that works in the first place.
Since HueForge makes different use of colors by stacking thin layers on top of each other, I was wondering which layer height it usually uses to get the best effect.
So generally speaking, for most images, we'll print at 0.8 and 0.4 layer heights, or their closest equivalents. And a 0.4 nozzle can print 0.4 just fine. You may have to slow down if you're on a really high-speed printer, but otherwise it prints just fine. And if you're on a printer that has, like the Prusa's that have profiles for 0.5 or 0.7, just use those instead and change those in HueForge and tell HueForge that's what you're using. You don't have to be stuck at 0.4 and 0.8.
I've seen some really stunning pieces of art at the booth of HueForge and wanted to know how many colors you usually combine for one image.
Right. So the more complex HueForges actually still often only require 7 or 8 colors, but you may reuse colors multiple times. So one of the things that I do is I'll separate into color ranges, color domains, and you do the black and your white multiple times. You'll have your shadowing with your black and your highlights with your white multiple times as you go, but you won't necessarily have that many unique colors. I have hit 11, but that's the most I've ever done.
Due to the layered nature of the HueForges, the prints really have some depth and almost look like oil paintings.
Yes, you can. That's one of the things I really like. And actually, a lot of first-time users will ask, can we turn it over and print it flat on the bed? And I say, no, you can't because it's all layer swaps. And then they play with it a bit, and then they say, I don't know why I wanted that. I really like the texture. The texture is part of what makes this really cool when you pick it up. And I do think like you get some tremendous depth effect out of HueForges sometimes, like if you go for it. And I think that little bit of actual depth really, really boosts that appearance of artificial depth.
On a standard inkjet printer, you use CMYK to create all of the colors. Why doesn't HueForge use this approach?
So because HueForge is all swap by layer, and I can make it not swap by layer, but I like that everyone can do it with their printer by being swap by layer. Because it's swap by layer, you can't skip stacking a color, you can't add, you can't put two colors in different orders. And so you can't you can use CMYK filaments, but you're not going to be able to do the same kind of CMYK effects because you can't put two colors in the same layer. So the layer-based nature of it, which makes it more available, also limits what you can do with blending colors like that.
So HueForges use multiple different filaments for every print, but do you really need a 3D printer with a multi-material system to make them?
The only thing you need is a printer that will let you pause and change filament, add a layer height, and replace it. So an M600 or a pause command that lets you unload and reload, that's all you need. Yeah, the AMS, the tool changer, the MMUs, those all make the job a lot easier. The ERCFAs, they all make the job easier, but they aren't required. And a lot of times you're under your 5 swaps is a pretty average number of swaps, so that's pretty doable.
So where do you start if you want to make your own HueForge?
So you buy the software. It's $18 for personal use. You download it, and then you drop your image in, and you start adding colors. Now it'll come up with a black and white settings for you. And a lot of people just sit in the black and white. They get some good filaments, and they get really good at handling the black and white hues. And they make amazing black and white images, and they're happy with it. And then some people go for more colorful images. But you basically just bring in your filaments. If your filament's in the library, you just check it as owned, and then it sorts up. And then you can say, okay, I'm going to drag these filaments into the image because I think they're the right colors. They're basically the color of the image, or they're a theme that I want to make this image color. And then HueForge will just show you what it's going to look like, and you can tweak your sliders to get the way you want it to look. And then go ahead and send that to the printer.
If I made a beautiful HueForge, can I sell it?
There are commercial licenses available. If you want to sell prints, it's $45 annually. And if you do buy the personal, you can upgrade at any time. It's $40. If you want to sell prints and digital files, it's $100 annually.
Okay.
Or there's a lifetime commercial, which is $250 annually, or $250 lifetime. It is 2 years of updates that come with that. You keep all your rights and usage rights and sale rights, but there will be maintenance fees for more updates after a couple of years.
Most of the HueForges they showed really embraced the contrasty style and didn't really aim for photorealism. So I was wondering what the limitations of the tool and the process still are.
So I think that it's interesting because a lot of people, when they get it, they think they can just drop a photo and it'll give them everything they need to do to just do it. And I understand why, there's the CMYK photolithophane maker that'll just do that for you. So a lot of people who've used it and really enjoy it and do well at it have embraced the stylistic, basically the medium limitations as an art form. But there is still room to make it more photorealistic, but you run up against, as I said, the major limit is how much depth you put in the image. And if you put too much, it becomes very hard to resolve the image in your eyes when you get close. The other thing that's kind of a limitation right now, and I'm really kind of wrestling with, is human color perception, and the fact that what you think is one color may actually be a completely separate color. And so this idea that I'm trying to assign these colors automatically and locations automatically, but you're putting in the wrong color filament and it can't match. So that kind of thing, human color perception is also a real issue with this.
HueForge is already able to create some stunning images, but I was wondering if there's still room for improvement.
Absolutely. So the way HueForge works now, you define the mesh first, and then you assign your sliders to set your colors. When the new version that's coming out, I'm doing a presentation on it in just a few minutes, is color match. And what color match does is so you set your color palette by setting your sliders and your colors, and it builds the mesh based on the closest matching colors in your palette. So the mesh gets built from the colors you pick. And so you have full control now. It's actually easiest to think about where if you have an image that's all flat colors, if you have a tag like this, right? And you have red, white, and blue in it. And you could just set where if you wanted the red on top, you could move the red slider up, and then the red would move to the top. And if you wanted blue on top, you do the same thing. So it actually is really great for this kind of thing, or like hard color images, but it's also able to do some really, really high multicolor images. It isn't without its issues, and that's why it's not released yet. But it is, I think, the way forward for people who really want to hit color in HueForge, because it's hard to get color right. And if you can just have the image, the mesh modify itself to match your colors, then that's an easy way to go.
So in order to use HueForge properly, not only the filament color is important, but also the TD value or transmission distance value. It describes how opaque a filament is. The higher the TD value, the more transparent it is, and the more layers you need to print on top of each other to fully block the last color from shining through. Yet the more layers you need, also the more use you can achieve. You can figure out the TD value with test prints, but I also saw a nice gadget that they sold, which makes finding that value easier and automated.
The unit's called a TD1. It was actually designed by Ajax, one of my moderators. And this one's not plugged in, but when you plug it into HueForge or you just plug it into power, you can just insert a strand of filament here and it will give you the value that you need, the transmission distance or TD value that you need. It isn't required, you can do prints, but it does certainly make the process a lot easier. It attempts to do the color, but we're running up against the limits of the sensor inside with a tiny strand of filament to get the color. I'd say about 30% of the time it nails the color. About 30% of the time it's the right shade but the wrong brightness, and you can just adjust that pretty easily. And then about 40% of the time you have no idea what it's doing and why it's telling you the color it is. But there is room, the firmware is being updated continuously, and there is room for us to improve the color, I'm pretty confident. The issue is that for different colors, you need different settings on the sensor, and the amount of time to run through all of that is long. So I think we can figure out a better color, but it's never going to be able to tell you that this spool of red is a different, if two spools from the same manufacturer are a different tone shade, but it should be able to tell you that they're red, green, blue, yellow, and pretty close.
Since there is a vast selection of filaments available from different manufacturers, I wanted to know if there are some colors that work well and others that don't. Might cheaper filaments even be better? Because with fewer pigments, these might have a higher TD value and work better.
That can be the case, especially for a traditional, the traditional standard luminance model of HueForge. The higher TD filaments are often much more useful, and so the cheaper filaments can be much more useful. However, as you get into some of the slightly more advanced filaments, you start to want to get saturation fast. So you want a lower TD filament on top to get to that hard color fast, so you don't have to have a really tall print that because the problem is if you make the print too tall, when you get up close to it, the illusion of the image falls apart.
I saw some of their own materials and was curious why they made them.
So there's a lot of filaments out there, a lot of colors out there, but partially no one's been tracking what people need. But one of the issues, a lot of people, we have people who want pets. They want to do their pets, and all the browns, for instance, are very, very opaque. Because of the pigments, because of the process. I don't know exactly why, but they're all very opaque. And so when you put a layer of brown in to get your fur brown, you lose all your shadows. It just turns brown immediately in one layer, solid brown. And so things like that, there's some edges where dark colors are always low TD. And while that can be very good and you can use those, you oftentimes want to be able to blend into those hard TDs. So I've created a line of filament. It's just 4 colors and 5 TDs that are darker filaments with higher TDs so that you can actually blend them.
As a final question, I wanted to know what Steve is most proud of when seeing what others made with his tool.
Personally, I'm most interested and proud of the faux materials because I really like the idea of being able to expand what you can 3D print by a little trickery and fakery, but being able to expand and say, I have wood, I have stone, I have things like that that really look like what they're supposed to be. And they're thin and they're easy to, relatively easy to print. But then some of the art that people have been putting out is really amazing. And I'm really not an artist. I'm more of an engineer. And so I'm more on the faux material side. But, Ian and Cyanide Sugar, Esther have been putting out some amazing artwork that I'm like, these are just incredible.
If you want to try out HueForge yourself, check them out at thehueforge.com. Within all the really amazing projects shown at the Rocky Mountain RepRap Festival, I stumbled upon a booth that showed off 3D printing gold. This is Stan Baldwin, who left 3D prints made from different materials outside for 7 years.
My name's Stan Baldwin. Company name is 3D PT, based here in Aurora, Colorado. So I did an experiment starting 7 years ago, where I was getting filament samples sent to me. I was working for a blog company at the time, and so they sent us these weird samples to try and test them and endorse them and sell them on their site. And I was at a tiny home festival, And people are asking how the prints last outside. So I started an experiment with that. And I eventually ended up leaving that blog company, but I kept the experiment going in my backyard. What you see here is each sample has a control behind it, as well as what was exposed outside. And these were hung on a 2x4 block of wood and hung on a west-facing fence in Denver, Colorado. And so I kept all the controls inside and just had them on the board, and it was a west-facing fence, so it took the full brunt of Colorado weather for 7 years. This year I got some new neighbors, so I had to finally take it down because they were starting to do a lot of yard work and everything. And you see all the different materials, so I've got kind of these odd composite PLAs, metal PLAs, TPU, more PLAs, and a lot of PLA PHAs. These are PETGs and co-PETGs from mostly ColorFab. Do have an ABS sample. So this is actually Eastern. Some other oddball ones, like this is polypropylene. That was like a one-off thing I got. A lot of weird ones. And this is a carbon fiber. Weirdest one's probably lay brick, as well as Tallman nylon. I started this before Recreator came out with the pop bottle filament, so this is a different company. But this is how pop bottle figures outdoors, and also have some oddball hemp samples.
I was really curious to find out what he learned in the 7 years.
First off, really secure your experiment, because it did get knocked down a couple times by squirrels. Probably the best materials are going to be your PETGs and nylons. PLAs easily degrade within 1 to 2 years. And I didn't bury them in the ground or anything. They were just hanging out, so they did get wet and dry out. I just didn't print a lot of ABS, but I had fun seeing how some of these weird ones like wood fill and cork fill behave, as well as the protopastas.
What kind of changes did he see in the materials? And did they break because the experiment fell down, or did they break because they became so brittle?
I think a lot of them broke from just falling, hitting the rocks, and so that's a couple of these PETGs and PLAs. I think a couple of them might have eventually gotten a hit and just never saw it. So there's some bits underneath where it happened. You have to dig those up at some point.
So which material would he recommend for outside use?
Pretty much all the PLAs were pretty bad. So you can see here, like this prototype supply PLA went from pink to this. Yeah, so that's the color change, but also just the PLAs in general were all real brittle. So yeah, PLAs definitely, you know, I've seen them used for gardening and stuff. If you don't mind them degrading. Any of the carbon fiber ones would definitely work real well outside if you don't mind black. This is conductive PLA here. If you want something that'll actually last, like probably PETGs or nylons, because like this just lost some color. Yeah, so it's still it's still pretty good.
I was curious why he chose specifically that sample.
Yeah, so this is a standard chip that I found on Thingiverse. So it's the same file for all these. And I did that just because it's got these steps and it's got the thicknesses. I think it's 0.1, 0.2, 0.3, 0.4 total thickness. So I just pretty much just tried to have the same file, which was fun when I lost that file a couple times. And then make sure, pretty much just print them to factory recommendations for the material. So I tried to keep that part as controlled as possible, as well as having the two pieces. So they printed at the exact same time, and just one got outside and one stayed in.
I personally found the results really interesting and wonder if I should do the same ones myself as well, because I miss some materials that we use these days quite a bit. Stan did regular videos on the progress of his experiments, which you can check out on his YouTube channel, and he also sells a full report for a small fee. I would really like to know what your experience with different types of materials left outside is. Did you have some particularly good or bad experiences already? Or what would you be curious about? Leave a comment below. This was the first part of the Rocky Mountain RepRap Festival 2024 coverage. Make sure to be here for the next one, where we take a look at a library but for filament colors, and an open source EDM project that lets you machine even the toughest materials with the power of sparks at home. Thanks for watching, everyone. I hope you found this video interesting. If you want to support my work, head over to Patreon or become a YouTube member. Also, check out the other videos in my library. I hope to see you in the next one. Auf Wiedersehen and goodbye.